Today we will discuss normality test. Normality test, there are so many ways through which we can test normality of the data. And it's most important because data should be normal before proceeding for any statistical analysis. So normality test is the most important requirement for the data is data should be metric. It is not applicable on the categorical data. It is not applicable on the non-metric data. Data should be collected on the ratio scale. So that normality test can be possible. So there are a number of the ways through which we can apply this data. We can check normality. Number one, descriptive analysis, skewness, kurtosis, values we have to check. Shapiro test, box plot test, PP plot, and QQ plot. And one by one, till the end of this video, we have to check normality by each and every method. So let's go to our SPSS file. I have taken, here is data view, minor mine output. Output means because these are the mines. Mines, one is privately owned people mines and two is government owned mines. And this is the output by the workers, those are working in these mines. And these are the total number of the data. You could see here, total number is 44. Total number is 44. So 44 workers data I had collected. And variable view, you could see here, this one is the minus, it is just a number we had allotted to workers, so that would be nominal. And we had collected mine privately owned, and this one is the government owned, that is also just a number, so that would be again a nominal scale. And output is that is metric data, that is at the ratio scale. So we are this normality we have to check only for this output. So what we have to do, we will go to analyze descriptive statistics, and this descriptive statistics you could see here, explore. In this explore output, here is both these data, we do not require. Output is here, output we have to shift in the dependent list. Statistics you could see, descriptives, yes, outliers also we require, then we will continue. Then plots is no stem and leaf, histogram, and then normality plots and test, then we will continue. And we have to check whether this box is checked, clicked both, because we require data output statistics as well as plots also. So then we will press OK, and this is our output. Output you could see here, total number of sample size is 44. Missing values, not a single missing value in my data, so total number is 44. Then we will copy this data descriptives in my Word document, then I would explain there in my Word document. I had copied here, these are the descriptives. So through descriptive analysis, we will check mean through mean, median, and mode, as well as we have to check through this skewness. Here is skewness, and as well as we will check through our, this one is the skewness, and our kurtosis and skewness, right? So mean, median, mode, because we had already studied in our statistics, mean and for the normal data, mean equal to median, median equal to mode. If all these three values are equal, that means our data is normal. So we will apply this formula, normal distribution, mean equal to median equal to mode. You can see here, normal distribution, mean equal to median equal to mode. So what is through this formula, mode, if we would like to calculate mode equal to 3 median, we will little bit elaborate. Mode equal to 3 median minus 2 mean, right? 3 median minus 2 mode, right? 3 median 40.50. Right, this is the median value. Median value is this 40.50, right? 40.50. We have already checked here, and mean value is 40.68. You could see here 40.68. This is our mean value. So 3 multiplied by 40.50, 2 multiplied by 40.68, right? And this is the 121.5 and 81.36. This is the, and finally mode value is 40.40. Mode value is 40.40. So here is, you could see it, mean, median, and mode. Mean, median, and mode. Right, so 40.680, all three values are little bit equal. So that means we can say our data is normal, right? Next, through positively, this one is the through skewness, and we will talk about this skewness and kurtosis. Skewness, we know, bell-shaped curve. That means this is our normal, our data is normally distributed. But when our data is positively skewed, we can say, right, what is positively skewed? In statistics, a positively skewed or right skewed distribution is a type of distribution in which most values are clustered around the left tail of the distribution, while the right tail of the distribution is longer. That is flattened, right? And when we talk about this data, this one is the data. Here is negatively skewed distribution, refers to the distribution type where the more values are plotted on the right side of the graph, where the tail of the distribution is longer on the left side and mean is lower than the median, and mode, which is might be 0 or negative due to nature of the data. So you could see here that is flattened. So this kind of negatively skewed, this is positively skewed, this is negatively skewed, right? So now we will check our data. This is the normally distributed, right? This is the normal data, bell-shaped curve. So we will see in our statistics output skewness and kurtosis. That's the most important thing. How we have to, first we have to calculate their Z score, right? How we will calculate our Z scores. Now you can see here. Z score, what we have to do, we will divide this value. I mean, this one is the statistics by the standard error. So then we will get the Z score. Here is Z score. Z score here is we want to calculate. So this one is the 0.139 divided by 0.357. Right? What is this? We had to calculate, we want to get this value 0.39 and it would be divided by 0.357. So our value is 0.389, right? And same with kurtosis also, that would value, these would value would also be this would be 0.728, right, divided by 0.702, right? And these are the all are negative value. There's the minus sign is here. So Z score should be, if your Z score is minus 1.96 to plus 1.96, that means if data is falling in between these two values, that means your data is normal. So in our this case, skewness and kurtosis values are falling in between these two values, so our data is normal. Again, from the second point, skewness, kurtosis, descriptive analysis, we have proven our data is normal. Then we come to the Shapiro test. In Shapiro test, we could see here, this is our table, and again I'm copying this table in my Word document right here. I will copy this data here, right? Shapiro test, you could see here, this value is greater than 0.05. This value is greater than 0.05. So in this case, what will happen? Null hypothesis will be accepted. Null hypothesis will be accepted, right? Null hypothesis will be accepted. It means this data is normally distributed, no significant difference in the data. Right, this data, that means that is normally distributed. That test is also proving our data is normally distributed. Correct. So this one is the second one is the Shapiro test. Then we come to the box plot test. Simply that would tell us outlier, basically normality also. So now I will show you. In this we can say box plot, right? Here is, you could see no outlier is here. Now I would like to show you, but before box plot we will discuss last. First is QQ plot. QQ plot means here is this one is the data. All the data is this one is the on the straightforward line, or is the surrounded by this line only, and then only we can say this data is normally distributed. Little bit is this one is the data is away from this straight line, otherwise maximum data is falling on this, so we can say our data is normally distributed. And this histogram is also a kind of this well shape. And I would like to show you one thing. When we have to go to descriptive statistics and frequencies, because this the bell-shaped curve should be reflected here, I would like to see along with the bell-shaped curve on this histogram. So what we have to do, output we have to shift to the right side box, and statistics, I don't want any mean, median, mode because I have already got it. And charts we have to press histogram, select and click on this box, show normal curve on histogram. Then we will continue, and then we will press OK. So you could see here, this data is almost normally distributed. This the bell-shaped curve is also here. Then we can also report this thing in our word content also. Then we come to the here is QQ plot. I have already shown you, right, this thing. And now we have to go to analyze, descriptive statistics, and PP plot also, right? PP plot also. For this output, reset this, and again output data is here, and then we will press OK, and we can see here this is our PP. This data is showing our data is normally distributed. Now I would like to show you one outlier case also through box plot, right? Let me change this value. You can see this data is almost 40s values, nearby 40s. Let's say I will change this value around 90, right? So you could see here how it is reflecting in the box plot. Analyze, descriptive statistics, and explore, right? And again we have to shift this data, and we have to go to plot, right? Histogram, normality, right? Continue, statistics is again outlier, and we will press OK. Now you could see here, here this data is right, because 90 value shows outlier, you could see here, and this data is outlier, is away from this line. And we can see here box plot, you could see at this part, right? I'm copying this part in my Word document. There would be more clarity, right? There would be more clarity. You could see here, I will paste it here. And now you could see here this part, star 44. That means 44 number respondent is outlier. You could see here 44 number respondent is outlier, and we should remove this outlier because this is not falling, this is not normal data, and that is outlier. Obviously it is reflecting here. Now in these values, all the values are little bit, and just because of this, mean value would also change because of this 90, right? Because it is this the, you could see all the values has been changed here, right? After again, when I have changed this value 90, you could see here, there's the lot of difference in, I mean, this one is the, in the histogram significance, you could see here. That means 0.000. Earlier Shapiro test was that was more than greater than 0.05, and now it's less than 0. That means we are rejecting null hypothesis, and null hypothesis, there is no significant difference in the data. But now we are saying our data is not normally distributed. Correct? So I'm sure this kind of normality check before starting any statistical analysis will be helpful to you. You can use any one of the any one of the method to check your normality test. That would be helpful to you. And your data should be normal, then only you have to go ahead for further any statistical test. I'm sure that would be helpful to you, this video. Thank you so much.